we understand work as labor or effort, but in terms of physics it is totally different. In day-to-day life, a person may be saying that suppose a person is holding a block of 1 kg or 2 kg for let's say 1 hour, 2 hour in his hand, and after 2 hours he may say that I got exhausted and I have done so much work. But in terms of physics, he has not done any work. In physics, we define work as the dot product of force vector and displacement vector. So work, which is itself is a scalar quantity. So work is a scalar quantity and it is dot product of F, that is force vector and displacement vector. So this is similar to A dot B is magnitude of F, magnitude of S, and cos of the smaller angle between the force and displacement vector. Remember, it is a smaller angle. Suppose over here the force is like this, displacement vector is like this. So there are two angles between these two. One is this, the other is this. So we shall be taking this angle. This is going to be the angle which is going to be taken in Fs cos theta. In cos theta, this is the angle which has to be taken, not the bigger angle. So work is the dot product of force and displacement vector. Also remember, work is always of a force. If someone says what is work done, always ask of which force, by which force, work of which force. There may be so many forces which may be acting on the system at one time. Then be particular, be precise, that is work of which force. So now, as work is F dot S Fs cos theta, now cos theta, this is obviously magnitude, this is positive, but now cos theta term, it can be positive also, it can be negative also, and this term, it can be 0 also. When is positive? When this angle is acute between force, if this is force vector, and this is a displacement vector. If the angle is acute, that is less than 90, so this is going to be, thus work, it is going to be positive when it is acute. So it is going to be positive when theta is acute angle. When it is going to be negative, when it is going to be negative is when it is obtuse. We know that is cos 90 plus theta. Over here, if you see the quadrants, this is first quadrant, this is second quadrant, this is third quadrant, and this is fourth quadrant. Over here, all is positive, here sine is positive, tan is positive, and in fourth, cos is positive. So obviously, cos 90 plus theta is going to be negative. Over here, it's only sine is positive, cos 90 plus theta is going to be negative. So it is, the work is going to be negative when theta is obtuse. And what is theta? Theta is the angle between the force and displacement vector. If it is acute, the work of the force is going to be positive because cos theta is going to be positive. If the angle between force and displacement is more than 90, it is obtuse, then cos theta is going to be negative. As a result, this is going to be negative. As a result, the work is going to be negative. And when it is 0, when it is 0, when it is 90 degree or pi by 2 radians. Obviously, that is cos 90 equal to 0. So when the force is in this direction and the displacement is at an angle of 90 degree, that is between the angle between both of them, that is 90 degree, then it is going to be equal to, work is going to be 0. Like when it is 0 when theta is pi by 2 radian or 90 degree, as the case of circular motion. When the body is moving in a circle, we have done it, that is centripetal force is in this direction and the displacement is always, small displacement is always perpendicular to this. Displacement vector is in this direction, angle is 90 degree. So as a result, the work done by the centripetal force is equal to 0. The earth is rotating about the sun and it keeps on rotating. When the centripetal force, it doesn't do work, so it is neither giving some energy to the system nor it is taking away. It is just letting the system, letting the body move in this circle, in the circular motion. So this centripetal force just provides that force so that the body keeps on revolving the circle, it doesn't do any work. So as a result, the system energy, it doesn't change. Work and energy, will come to that work and energy, they are interconvertible. The unit of work over here, the unit, if we talk about the unit, SI unit is joule. When we talk about the energy also, we'll come to that later on. That is work and energy, they are interconvertible. Work can be converted to energy, energy can be converted to work. So obviously both of them, they are going to have the same units, that is the unit is joule. So once again, work is the dot product of F dot S, it is a scalar quantity, it is magnitude of F, magnitude of S, displacement, and the cos of the smaller angle between the force and displacement vector. This can be positive. When this is going to be positive, when theta is going to be acute. This can be negative, this can be negative. When theta is obtuse, then this is going to be negative. As a result, the work is going to be negative. When it is going to be 0, when the angle between the force and displacement vector is 90 degree, then certainly the work is going to be equal to 0. Do not confuse this definition, which is in physics, which is followed, with the general terms which we use in the everyday life. So we have work is number 1 F dot S, dot product of this, which is equal to magnitude of F, magnitude of S, and cos theta. Now you may be given directly the magnitude of force vector, the magnitude of displacement vector, and the theta between the two. Like let's say there is a body over here, this moves 2 meter, and there is a force which has been applied, let's say 40 Newton at an angle of 60 degree. So now we directly say that is the magnitude of F is given 40 Newton, magnitude of S is given as 2 meter, and the theta between the two, smaller angle, is given between the two. So we directly use this one. We don't get to this one, we directly use this one because all the things they are directly given. They are given on the platter. So F is, the work is going to be magnitude of F, that is 40, magnitude of S, 2, cos of what? Cos 60. Cos 60 is what? Cos 60 is 1 by 2. So 40 into 2 into 1 by 2, that is 40 joule is the answer. So when we are given directly the magnitude of force vector, the magnitude of displacement vector, and the theta, the angle between the two, we can directly use this and we can get the answer. Suppose now it is given as, instead of diagram like this, it is given as force vector is given as 2i plus 3j plus 5k, and the displacement vector is given as, suppose, 3i. So over here we see that his body is constrained only to move along the x-axis. It is moving 3 units along the x-axis in the positive x direction. So over here, this is given in vector notation. Force is given in vector notation. Displacement is given in vector notation. So what we do is, now we use this. So work is 2y plus 3j plus 5k dot displacement vector. What is the displacement vector? Displacement vector is 3i cap. So obviously when we multiply 2i dot 3i, so this is going to be 6, 3j dot 3i, that is, you know, j dot i is going to be equal to 0. Similarly, k dot i, that is going to be equal to 0. So just multiply I with I, that is 2i dot 3i, that is 6 joule is the answer. So work in this case is 6 joule. So when the force and displacement, they are given as vectors, so use F dot S. When they are given as magnitude of force is given, displacement is given, and the theta between the two is given, smaller angle, then directly use magnitude of F, magnitude of S into cos theta.